Super. So let's start with the second one, which is going to be always about IP audio client. We have a lot of functions new in there. And this is going to be about the API. Also, the API is a function that is still not yet available, but we received many requests in these recent months. Mainly, I think, because our legacy products are having different interfaces that you can interact with through API, like CGI, TCP, UDP, or serial. While in this new 4XX product line, based on IPAM 400, we still don't have an API. So we decided to deploy one. And in this session, we will see this API that we are implementing as we speak. I expect this API also to be available by end of Q1. So probably the same time, more or less, when we will release the MPA 400, we will have the API also available. And let's dig deeper into this API thing. So first of all, let's get an overview about the API. An API is mainly used for the main purpose of enabling the interaction between different software applications or services, right? So in our case, for IPAC, what we intend is the possibility to enable the control and monitoring from a third-party application or system. For example, if you want to control and monitor devices from an automation system controller or from a customized web application. A good example was the one of the question before about the cloud service. I guess that function through an API would be available and would allow you to have two independent systems. One is the cloud service, the other one is our device, dealing between each other. So the backend on our device could deal with your cloud service through the means of an API. That's an example. Let's go back to the IPAC case. APIs, in this case, are used, or I mean, what we intended to do on the IPAC and why. Because API are used all over across the web to make the web services accessible between clients and servers. Since our application on IPAC is mainly controlled by a web service running on it, and it's important to understand here because it's mainly controlled by a web service. When you access through the web interface, you are using our web service exposed to control the application on our Linux embedded system. For this reason, since we use already a web service, we preferred to adopt an API that is modern and compatible with the current technology landscape of these web services. And if I go a bit more into the details, what you see on the screen now are the pillars of the API architecture that we are implementing. Point number one is that we defined the IPAC to be the server, which is listening for incoming requests from clients and handling requests accordingly, replying with the defined responses. Number two is that we want to stick and follow the REST API best practices. The whole web is mainly based on this REST approach, so we opted to follow the same. REST mainly defines a guideline to help developers and building APIs. Some key points of our implementation are the ones A, B, and C. Message formats should be using JSON with a clear schema definition describing properties and parameters. The JSON messages should be sent in the body of the call when the call is performed. The methods, the verbs that we work with are the ones used by the HTTP protocol. Each call must be processed with the right method, verb, to get the expected result from the server. So in example, if I want to retrieve the current status from an IPAC device, I will send a GET request. Get, put, delete, update, these are all verbs part of the HTTP protocol. So we keep it standard. You send a GET request to the appropriate endpoint and you will get back the status. If instead, for example, you want to set the volume of the device, you will send a PUT request, a PUT call to the endpoint exposed by our server, by our IPAC. how endpoints work are through their implementation into the Uniform Resource Identifier. URIs, you know what a URI is, I guess. So they allow us to access the corresponding resource, identify the corresponding resource that we want to access. So these are the REST best practices. Point number 3 is that we base our implementation on HTTP. But the truth is that the API we want to have in place is protocol agnostic. So if one day we want to deal again with TCP or UDP, we could. We keep the same JSON schema, we keep the same methods available, and we could transpose it into TCP or UDP quite easily. Having these building blocks, this is what allows us to achieve. Is this suggested? I mean, is it really needed to use TCP or UDP? From my perspective, no, mainly because of security. HTTP allows us to implement TLS and secure the connection and the encryption. So that's mainly the reason why I would not go for TCP and UDP again. Always staying into the security, we are going to the 4th point, which is the authentication of the API. Each call, by default, must be authenticated using an API key, which is one of the most modern ways to authenticate calls towards servers, towards web services. Without an API key, the call cannot be processed and we return a 401 unauthorized status code. So, on top of this, we also will have the possibility of avoiding using an API key in order to broaden our compatibility with systems that are not able to implement an API key into the HTTP header. Again, from my perspective, this is not suggested, but of course, I cannot have the power to control all the systems installed around the world. And we still have systems around that are not using security at all, maybe just because they are protected from another level, another network level. So they are maybe totally closed and there is no need to have an API key in place. And if this is in place and if the customer ensures the right protection, of course, they can also use and adopt the no authentication option that we will add in the feature. As a practical example, this is how a call would work. So we see an example of a GET request to retrieve the status of the device. It is quite simple and straightforward, as you can see. The client, a web application in example, can send the call to the IPAC device endpoint, so the URL that you see there, the API v1 status, passing the previously generated API key in the HTTP header. So the first step for this to work will be, if you need to use the API key, of course, generate the API key in the web interface of the application and having it inserted into the HTTP header of your web service, of your web application. So when you do the call, it will be authenticated. When the call is received on the IPAC side, it is processed and the response will be generated and sent using the JSON format that you can see as an example of the status reply. We are returning device info, the hardware type, IPAM type, MAC, and all other information. There are also, this is a quite big message to be honest, is a network, there are network informations and so on. Going forward and to tell you exactly which functionalities we exposed into this API, I have split this into 2 tables, not by a case, but because the first table shows you the common functionalities that are common across all Barix devices based on the IPAM 400 and that we are dealing with as we speak. By common functionalities, I mean that these functions are present in all new generation devices. While the second table is specific for IP audio client. So let's go quickly through all these verbs here. We have the GET request to retrieve the firmware version, the GET or PUT request to get the current volume configured or set a new volume, and this is the master volume. We have a PUT request to mute or unmute the audio output, In this case, we will have a Boolean true or false to mute or unmute into the same call. We have the get and put of Sonic IP, where we can get the Sonic IP configuration and eventually enable or disable the function entirely. A put request to reset to defaults the device, a put request to reboot the device, a get request to retrieve the whole system status, software version, licenses, network configuration, the same thing that we saw here, but in a more extended version with a lot of information. And in this table, instead, we see the individual verbs, individual requests of IP audio client specific. We can retrieve the current source configuration. We can enable or disable a specific source. We can set the volume of a specific source. We can get the current status of all audio sources, if they are playing, if they are monitoring. What is a monitoring? Is when a source is not playing. Maybe you have Barix radio playing at number 5, but you have SIP at number 3. The SIP will be in monitoring phase until it's not received any audio. So we have this audio manager, as we call it in IPAC, which monitors all the sources continuously. Of course, all the active sources, not the disabled ones. Then we have the audio files, which allows you to retrieve all the audio files currently stored in the local memory of the device. In this way, you are able to manage the files as well. You need to have a local file source configured, and then you can trigger the playback of an audio file from the API, or stop the audio file. Retrieve the status of an audio file. So after you send the play, depending on the use case and application, you can even retrieve what this audio file is doing at the moment. Is it playing or is it stopped? And we have a new function in the firmware, which is called loop, that allows you to trigger the playback of an audio file, and it will loop over and over and over and over again. Just to give you a quick briefing on this functionality and why is there in IP audio client. This is because we had a request for noise masking, sound masking. And this is something actually you can think about as well, about IP audio client. This is an increasing functionality that is being requested. And the goal, if you don't know, it's to increase privacy in an office. So that multiple employees, like with a distance of 3 meters, for example, between each other, they cannot hear themselves clearly. And this is done and achieved simply by playing something like a white noise, but it is being a bit modified, white noise into the speakers. And since we cannot have an endless file into the device, we have like a 30-second white noise, and this is looping over and over again. I am calling it white noise, but actually it's something more closer to brown noise because it has less high frequencies in there. So you cannot perceive it, but it is playing. So it's made oppositely to disturb, let me say, disturb the noise in the environment. So it generates some noise to make the conversation less understandable at a certain distance. So there is a whole science around it. So if you want to Google it, you type sound masking or noise masking. There are many different companies that I think they also trademarked the name of the application. So you can study a bit around this topic. But it's cool to see that our IP audio client allows you to achieve that. Documentation. Well, one of the most important thing about an API is its documentation. Without this documentation, you don't even know how to access the API, right? So documentation will be available and will be published as soon as the API is released. And we can also give you the API as a Postman collection. For those of you that don't know, Postman is a software that allows you to test APIs. And we will include, of course, all the explanation of the functionalities that it provides. I already listed them all here, but there, of course, this is just a quick overview. There is a wall, you can see an example on this slide. We have the whole schema definition with the parameters that has been passed in there and so on. So you will have this possibility too. As we said, it will be available by end of Q1 2022. Again, I will mention this again. If you need support, the help.barix.com is where we will publish also the API information and documentation. So whenever it will be released, you will find it here. And again, the same contacts that we saw before. Support@barix.com for technical, sales OEM and feature request, sales@barix.com. If you have a project, pre-sales@barix.com